In this short video, we'll discuss how to use the limit process to find the derivative of some of the basic functions. First, let's look at e to the x. So we know the domain of these functions is our real numbers from negative infinity to positive infinity. And we're going to use the limit process to establish a limit problem, as we know that e to the x plus h is a representation for f of x plus h. And e to the x is just f of x. So if we look at the numerator, we can use one of the exponential properties to expand it out into e to the x times e to the h minus e to the x. And then we can factor e to the x out to get to this limit. And we look at e to the x, since the variable of this limit is not x, it's h. So you can consider e to the x as a constant. So you can move it out. And the next problem is finding this limit. In this case, we cannot plug 0 into h because h is in the denominator. So we can use the graphical method to find this limit. And using the graph, you can see that the limit at h goes to 0 is 1. So by the conclusion, if f of x is equals to e to the x, then f prime of x, the derivative of e to the x, is e to the x, the same functions. This is one of the special functions when the rate of change of the function at the point is the same as the function's value. And the domain of the derivative functions is the same, the number line, right? Our real numbers, or negative infinity to positive infinity. Now let's look at the next functions, square root of x. The domain of these functions is also our real numbers. And we established this limit problem where square root of x plus h is f of x plus h, and square root of x is f of x. In this case, we're going to use the analytical method to find the limit by multiplying the top and the bottom by the conjugate term of the numerator. When you simplify the numerator, you get x plus h minus x. And you can simplify x and x. Since h is the only term left in the numerator, you can simplify h to the h in the denominator. The next step is to plug 0 into h. Then you can have 1 over square root of x plus square root of x. So if f of x equals to square root of x, you can conclude that the derivative of square root of x is 1 over 2 times square root of x. And the domain of this derivative functions is going to be our real numbers but 0, because clearly 0 can't be plugged into the denominator. Now, if we use the limit process, we can find the derivative of some of the basic functions. First, the derivative of a constant is 0. It is because the rate of change of the constant is 0. Second, derivative of x squared is to the x. The derivative of e to the x is e to the x. Derivative of square root of x is 1 over 2 square root of x. The derivative of x is 1. Derivative of natural log of x is 1 over x. Derivative of sine of x is cosine of x. And the derivative of cosine of x is negative sine of x.